Hello, everyone. Welcome back to Grade 10 Applied Math here with Mr. Stone. So, we're going to look at linear systems again. So, in Unit 3, Activity 2, we looked at solving system by substitution. Here in Activity 3, we're going to do another method, and we're going to try to put it all together into the three different methods that we have to solve linear systems. So, remember what we meant by substitution. So, I'm just going to quickly go over the steps again. So, in substitution, we have to basically get one of the variables by itself. So let's say here, for example, we get an expression for x. So we say that x here is -9 plus 4y. And we take that expression and we put it into another equation. So we take one equation and we rearrange it and we put it into the second equation and then we solve. Because the whole point was we had an x here originally. This was 3x plus 2y is 1. But if I replace x with this stuff here, this -9 for y, now we have y's only in our expression, and we are able to solve this. We have one equation, one unknown, y equals 2, which we do all our algebra. Then you take that number and you put it into one of the equations, and we get another answer for x, and we put them together, and we're finished. Okay, so that's how we solve the problem using a substitution. Now, there's actually a sometimes easier method, which I actually prefer. It's called elimination. Now, this only works if, for this special case, if we have the coefficients here, the numbers are the same. Or not only just the same, like, let's say, for example, here we have these invisible ones here, right? We have like an invisible one. Or not only if they're the same, but if they're opposite signs. We could do this in two different ways, but I'm only going to show you one of them just for now. Okay. We could have done it with the y's. But notice that we have a plus y and a negative y. So this is weird. Okay, I'll be honest with you. This is a strange idea. What if we subtracted or added our equations? You think to yourself, what does that mean? How do I subtract or add an equation? Well, let's just like we know, we can combine like terms. Let's take our equation here and our equations, and add them together, but only add the like terms. So let's only worry about the x's for now. So we have x, and we're going to add x from the first equation here, this first x, and we're going to add the other x, and that's going to give us 2x. That's going to give us, we have 2 x's. But what happens to the y's? Because there's a negative. So let's say we have y here, plus y, plus negative y. If I have one something and I add a negative, the same thing, they cancel out. We've eliminated the y variable. It's gone. Right? So we've added them together to get rid or eliminate one of the variables. So now we have 9 plus 3 though as well, so we still have to do that. We've done the x's, we've done the y's. What about this side? So 9 plus 3 is 12. And we can simplify this by rewriting it just as, without the y's, as 2x plus 12. And now the question is, what times 2 gives us 12? So what number, right, that's what this is saying, 2 times something, some unknown, is 12. And that's going to be 6. But the other way we can do it, the more precise way, let's say, we can divide both sides by 2. Right, because this is saying 2 times x, the opposite of multiplying is dividing, the opposite operation. So if we divide both sides by the same number, 2, the 2 divided by 2 cancel, and we get 12 divided by 2, which gives us a final answer of 6. So x is 6. Now you might think, oh, we're done. Yay, x is 6. But remember, with these problems, we have to do two things. We have to get x and y. There's always two numbers we're looking for. So we're halfway there. So now we take our number 6, and we can replace it in one of our equations. Doesn't matter which one. Let's take the second one here. So instead of x minus y is 3, that's going to be 6 minus y is 3. And might be a little bit tricky, but how do we solve this? So we're going to get rid of the x on the one side. So let's subtract x on both sides. So 6 minus 6, they're gone. And then 3 minus 6 is going to be negative 3. Now, careful with this negative. This was saying subtract y, which is the same as negative y. That's a really, that can really throw some students for a loop. The idea that negative and subtract are very similar, but very different, right? And this is saying subtract y, which is the same as adding negative y, which is confusing, I know. But let's just leave it at that for now. Okay, so we have this negative, but the whole point that I'm trying to get at is that we need to keep that there. It's still there. So now this is saying that negative something is negative 3. So the positive y is just going to be positive 3, right? If negative y is negative 3, then positive y is positive 3. And we have our two answers. X equals x equals 6, y is 3, and we just put it together. The final answer here is xy is 6, 3. And that's how we solve a problem by elimination. This part here is the same as substitution once we got our answer. The difference is we're going to do this weird step of subtracting or adding an equation. We have these two equations. Let's call it 1 and 2. We're going to add them together. And when we've done that, the whole point is to eliminate a variable. Let's try another one. So let's see what we have here. We have 3x plus 2y is 6. That's our first equation. And our second equation is 3x minus y equals 15. And if you notice, we have 3x and 3x. The coefficient, the number that goes in front of the x variable, are the same. But this time, they're not opposite signs. So how can we get rid of them if they're both positive 3? If I added these two equations together, I'd get 6x. Right? That wouldn't eliminate. We want to get rid of it. We want it to say 0x. So how can I make 0 out of plus 3 and plus 3? I subtract the two equations. Okay, so this time we're going to subtract. So 3, now with these you have to be very careful. It's very, very easy to make little sign mistakes where an answer should be positive or it should be negative when you write down positive or something like that. Just be very, very careful. So let's go through this slowly. 3x, take away 3x. That's easy. Gone, right? 0x. No x is left. Now we got to be tricky here. We got to be careful here. So 2y subtract negative y. So that's saying 2 take away negative 1. Right? So 2 take away negative 1 is just equal to, that's this take away negative, that's just like a big plus. So that's 3. So 2 take away negative 1 is 3y. And then 6 take away 15. 6 subtract 15 is going to be negative 9. We got to be careful with these numbers, right? So this isn't 6 plus 15. This is 6. 6 subtract 15, so negative 9. Now I can write that again without the 0x. So that's saying 3 times something is negative 9. Again, we can get rid of the 3 by dividing both sides by 3. And we end up with y is negative 3. So we have our y value. We eliminated our x by x, and we got our y. Okay? So we're halfway there again. We got our y. So now we take our y and we replace it in one of the equations. Doesn't matter which one. I'm going to pick the second one because the first equation has a 2 in front, and this one only has a negative 1. So there's less things to worry about. So 3x take away y is equal to 15. If I replace the y with negative 1, I put it in brackets to make sure I remember that there's a negative there. So I have 3x take away negative 1, and then that becomes like a big plus. So that's going to be plus 3. And then I'm going to subtract 3. That should be red. Sorry. I'm going to subtract 3 from both sides to cancel out the 3's. So I get that 3x is 12. What times 3 is 12? That's just going to be 4. Okay. I went over that algebra pretty quick. Apologize. Let's do that slower. So let's go. The y becomes negative 3. But then when I'm subtracting negative 3, that becomes positive 3 here. Then to get rid of my positive 3, because the whole point, right, I want x by itself, but right now x has a multiply by 3, add 3. So we're going to subtract 3 from both sides, because plus 3 take away 3 is 0. That'll cancel out. But then if I subtract 3 on the left, I have to subtract 3 on the right as well. So it's going to be 15 take away 3, which gives us 12. Then I end up with 3x equals 12. I get rid of the multiply by 3 by dividing by 3. Then I have to do it on the other side as well. So then I end up with 12 divided by 3 is just 4. And again, last step, step number 5, I write out my final answer. The xy is negative. I made a mistake. Excuse me 1 second. I apologize. I had the x and y's backwards. It's all right. So it's 4 minus 3 is our answer. So x equals 4 and y is negative 3. So xy is 4 negative 3. All right. So in the first one we did, we added the two equations to make things go away. This time we subtracted. Keep in mind, if the two numbers are the same sign, like here, for example, these are both plus 3, right? We subtract. If the numbers are opposite sign, let's say I had a 2x and a minus 2x, let's say. To get rid of these, I'm going to have to add. Okay? If the signs are opposite, we add. If the signs are the same, we subtract. Okay? Awesome. All right. So let's just do a quick review. So how can we solve linear systems? We have three different ways. Yeah. So our 3 ways are, first we did graphing. Right? So we could graph, or we could substitute, or this last one we just learned is elimination. So what do these look like quickly? So graphing, basically, just find yourself a Cartesian plane. You can use Desmos, or you can do it by hand. Put the 2 lines on there. Where do they intersect? That's our answer. Okay, so this would be our final answer. Substitution is when we rearranged, then substituted it in. Remember, substitute. So we substitute in an answer or term, and then we solve. And elimination is when we take our 2 equations and add them or subtract them. Okay, so that's it for today, for this lesson, sorry. The assignment basically has a graphing problem, a substitution problem, an elimination problem, and then a, well, how about we just go there 1 second. Let's see. This is the assignment. So it says solve this one by graphing, this one by substitution, number 3 is by elimination, and then 4 it asks you to solve with whatever you want. You can use whichever method you want here, okay? And then 5 asks us, gives us the answer. Answer is 2, 3. Come up with a system equation, so basically just 2 equations that have the solution 2, 3. And then tell me, is this the only answer? Or can you get another one? Is it possible that there's more? Anyways, all right. So that's it for today. And good luck, and I'll be talking to you later. Take care, guys.